Hello everyone, welcome to this next video in the series of Intro to Deep Learning. In this video, we'll be looking at some tips and tricks on how to improve and train our model faster. There are some hurdles while training and designing a model, such as overfitting, long training times, etc. Let's look at what these hurdles mean and how do we counter them. One of the problems is the randomness of the input columns. For example, if one column has values between 0 and 1, and the other column has values between 100 and 10,000, there is a huge gap in scale of these input features, which makes the gradient descent slower, because the model is trying to incorporate the different scale of the features, which could cause problems. Hence, to counter this problem and make it easier for the model to train to learn in a better manner, we normalize the data. So basically, what we want to do is to get all the inputs in a common range. This method is called normalization. So why does normalization work? As you can see from this 3D plot with errors, weights and biases as inputs, and when you draw the contours of this 3D graph onto the plane of weights and biases, we can see that it is way easier for the model to get optimal weights and biases during gradient descent when the data set is normalized. That is, when the data set is like the one shown on the right side. Now let's look at another problem. This problem is called overfitting. Overfitting the data. So overfitting is when model is extensively trained on a data set which it fits too closely. So now when the model is used on an unseen data to predict new values, it will perform poorly, resulting in a bad model. Hence, to overcome this problem, we use regularization techniques. There are multiple regularization techniques. Some of them are ridge regression, that is L2 norm, lasso, that is L1 norm, and dropout. In this video, we'll be seeing what dropout is. So dropout is a regularization technique used in neural networks. It prevents complex co-adaptation of neurons with each other. Essentially, what we do during regularization is we skip some of the neurons at random from the training cycle, effectively making the network shallower and faster. The neural net's fully connected layers are more prone to overfit on the training data. Using dropout, you can drop connections with 1 minus p probability for each of the specified layers. That p is called key probability parameter, and which needs to be tuned. It is one of the hyperparameters. This is what makes neural network shallower and avoids overfitting. This is how a neural network with dropout looks like. Let's learn some other useful tips, like random initialization. When you first declare the weights and biases of a model, you need to initialize them. You can basically initialize to anything because the model will learn during the training and adjust the weights and biases accordingly. Although you could initialize everything to 0 and start training your model, initializing them in a certain way has advantage over others. One of the more common of such ways is randomly initializing or random initialization, where you basically initialize the weights and biases with random numbers. This type of initialization technique is called random initialization. This serves the purpose of symmetry breaking and which helps the model train faster and achieve the optimal weights and biases during the gradient descent faster. Although the numbers which we use for weights and biases are very close to 0, but the values themselves are totally random. No, not every neuron does the same computation because everything has a different value, which in turn boosts the performance of the neural network. This is a Python code to initialize weights using NumPy random function. There are many other such ways like random initialization, Xavier and k-aiming. research to which are provided in the link provided in the description. So hope you guys learned about the various tricks you can use to make your machine learning experience easier and faster. Thank you.